this assessment asks us, why can't you add a third alkyl group using this strategy? And this strategy that we're referring to is already shown on the screen. It's essentially taking this activated methylene compound, this compound with 2 protons between 2 carbonyls, 2 electron withdrawing groups, and using that to deprotonate and then do an alkylation. Well, if we're going to say we can't use the strategy, well, let's imagine that we could. Here's what it would look like. Sodium methoxide would remove a proton. That's going to make a nucleophile to do an SN2 reaction to add the first alkyl group. Good. First, we can add 1. That works. We want to remove another one or add another one. Sodium methoxide removes a proton. In this case, we'll use bromomethane. We can do an SN2 reaction to add another alkyl group. If we wanted to use this strategy to add a third alkyl group, we would add sodium methoxide, our base, but what don't we have there? That's right, there are no more protons. And with no more protons, there's nothing we can remove. We can't make the enolate again. The reason we can't add a third alkyl group is because if we have 2 carbonyls, we have a maximum of 2 protons. We can only deprotonate twice. We can only add 2 alkyl groups.